Okay, so we've got another FRQ here, this time dealing with differential equations. So first part of this question asks us about a slope field and to sketch the solution curve that passes through the point. So the first one is through the point 0, 2. And so if we look at our slope field through that point 0, 2, we seem to just have a horizontal line, right? That our solution then is y equals 2 will be a solution, right? And of course, if y equals 2, the slope is always 0, so that works. We also have through the point 1, 0, we want to make sure that we plot those points well. And if I kind of come from this side, it seems like I'm going this direction. Come from over here, seems to be following the line like that. And so then there's my second solution. I'll just say that this is some y equals f of x. Okay. Just plot the points and then follow the curves. So let y equals f of x be the particular solution to our item and write an equation. So we're going through and it looks like we're going to go through the point 1, 0. So that means that we're using that one and we're saying y equals f of x. So we've already labeled that. So we need the slope at 0, 1. Okay. So we need to know for our particular one, right here we have, so for part B, we need dy dx at the point 1, 0, right? Well, that's going to be 1/3 times 1 times 0 minus 2 quantity squared, and so that's going to be 4/3. So that means that y minus 0 being equal to 4/3 times x minus 1 is going to be my tangent line. So if I want to approximate, f of 0, 1.0.7, then y is going to be approximately equal to 4/3 times x minus, x was 0.7, so 4/3 times 0.7 minus 1, and then move the 0 to the other side, we have plus 0. So y, therefore, is approximately 4/3 times 0.7 minus 1. And that's satisfactory enough for our approximation. If we wanted to, we could say yes, that's 4/3 times negative 0.3, which would be the same thing as 4/3 times negative 3/10, and so that would be negative 0.4 as a multiple choice answer. Okay. And now we want to find the particular solution. And so let's go ahead and see if we can recall this. dy dx 1/3. So let's go ahead and write that down to get our particular solution. So dy over dx is going to be equal to 1/3 x times y minus 2 squared. So first thing I want to do is separate the variables. So we're going to separate the variables. So I'm going to have dy over y minus 2 quantity squared is going to be 1/3 x dx. All right, so that means that y minus 2 to the negative second dy is going to be 1/3 x dx. Then I need to integrate both sides. All right, so let's go ahead and integral of y minus 2 to the negative second dy needs to be equal to 1/3 the integral of x dx. So for the left side, add 1 to the exponent. We see that this is linear in here. Divide by that exponent and then divide by the linear coefficient, which linear coefficient of y is 1 here. And then 1/3 x squared over 2, and we need plus a constant of integration. Okay. Now using my initial condition, right, the initial condition is 1, 0. So that means that negative 1 over y minus 2 needs to equal x squared over 6 plus c when x equals 1 and y equals 0. All right. So in other words, if x equals 1, y equals 0, I've got negative 1 over negative 2 needs to equal 1/6 plus c. So 1/2 minus 1/6 needs to be equal to c. And if I play with that, that's going to be 3/6 minus 1/6, which would be 2/6. So then I'm going to say that negative 1 over y minus 2 is going to be equal to x squared over 6 plus 2 over 6, right? Which that implies that negative 1 over y minus 2 is going to be x squared plus 2 all over 6. So that means that y minus 2 over negative 1 is going to be 6 over x squared plus 2. Getting there, almost. So that means that y is going to be equal to 2 minus 6 over x squared plus 2. And the reason for that is I need to take this negative, multiply it to that side, and then I need to add 2 to both sides of my equation. So I end up with my final answer. Okay. Now, where are the marks for this one? With separable differential equations, there's always going to be 4 or 5 marks. If it's a little bit harder, it'll have 5 marks. A little bit easier, it'll have 4 marks. But there's always a point for separating your variables. There's always a point for integrating, and this one happens to have 2 points for integrating. Correct left, correct right. Use of the initial condition with the constant, right? So use of the initial condition with the constant is also, right? So we see right over here, and then to the final answer. So there happens to be 5 points for that one. Okay. For part B, we need an equation for the tangent line. We're just substituting things in, and we need the approximation. So for part B, we have the equation of the tangent line. We have the approximation. There's only 2 points for part B. And then there's 9 points for each of these questions. So that leaves 1 point for this curve, 1 point for this curve, 2 points. Differential equations you should expect to see on your assessments. But if you have questions, you need additional practice, please reach out. Please search for that help. Okay. Thank you very much for your time. Have a great one.